Hey everybody, welcome back to another edition in geometry. It's Mr. Anderson here, hanging out with you. We're talking about section 3.4 today. We're going to talk about different types of equations of lines. Just like last time, this is something you've probably seen a little bit in Algebra 1, but we'll review it again this year. Okay, so let's start by taking a look at our objectives. First of all, we're going to be able to write an equation of a line given information about that graph, and then we'll solve problems by writing equations. All right, let's start out with our equations that we're going to talk about today. The two different types of equations we're going to talk about, number one is slope-intercept form. The other one is point-slope form. Let's start with slope-intercept form. Probably one of the most famous or popular formulas in math, y equals mx plus b. You're probably very familiar with that. And so in slope-intercept form, m, that's our slope. And then as it says here, b is the y-intercept. What we're really trying to do, as it shows you here, what we're really trying to do when we write an equation in slope-intercept form, we're just trying to find a number that we can put in for m, and we're trying to find a number that we can put in for b. And as you can see here in this example, y equals 3x plus 8, we've put in 3 for m and 8 for b. Okay, we'll do an example here and graph these and see what these mean. But again, we talked about slope last time. That's the steepness of the line, and b is your y-intercept. That's the point that you're going to graph on the y-axis. Okay. The other form that we're talking about today is point-slope form, not as widely known or remembered, perhaps. But this is the form here. It's going to be just y minus y1 equals m times, in parentheses, x minus x1. What's happening on this one? Well, remember m was slope from our other example there. Guess what? M is still slope. So in this case, the example that they gave us was -2 is the slope. So that's still our slope. We're still trying to put in a number right there. And where we're going to also put in a number is here where they've done that with a 5 and here where they've done that with a 3. The way that I kind of like to remember this is sometimes people have a hard time remembering which y to put the number in. If you look here in the formula, where the y is that has the little number 1 attached to it, and the little x with the little number 1 attached to it, x1 and y1 have little numbers on them, so we're going to try to put numbers in for them. Notice this y here and this x, it's just plain y and x. We want to leave those as x and y. Okay? So that's what we're trying to do there. And by the way, kind of just an interesting side note, this point-slope form is really just a different version of the slope formula that we talked about last time. They just moved some things around, but it's basically just a different version of that. Okay. Let's look at a few examples here then today. All right, so first of all, write an equation in slope-intercept form. So what that means is we want an equation that says y equals mx plus b. Okay, that's slope-intercept form. The line has a slope of 3 and a y-intercept of -3. Okay, so first of all, read these words here, and we want to say, what pieces of information do I have that will allow me to write this? Well, if you look here, we have a slope of 3. That's one piece of information. Another piece of information that we have is that we have the y-intercept of -3. And so remember, this, when it says slope of 3, that means that that's m, right? M is your slope, and y-intercept is b, so b is -3. So now we know what m and b is. Guess what? That's exactly the things that we need to know to plug in here. So our equation will just be y equals 3 goes in for m, and b would be a -3. Now, even though this says plus b here in the equation, it's a lot cleaner and simpler, just instead of writing plus a negative, just to write -3. So that would be a better way to do that there. Just write -3. 3 x minus 3. Okay, so now when we go to graph this, well, how do we graph this? Okay, there's a little trick that I like to talk about as far as graphing that sometimes people get confused. So you notice the b is the y-intercept. Okay, so here's what I like to say. B is where we begin. B is where we begin. So we're always going to begin with the y-intercept here. Well, the y-intercept, remember, it's negative 3 on the y-axis. So that means we're going to go down here, put a dot. So that's B, that's the y-intercept, that's where we begin. And then M, or the slope, is how we move. So from the beginning point that we have there, negative 3, this just tells us how to move. Remember the M is 3, so the slope is 3, but it counts as 3 over 1 when we count it out. So from here I'm going to go up 1, 2, 3, and over 1, put a dot. Up 1, 2, 3, put a dot. Up 1, 2, 3. Or remember, you can go the other way. You could go down 3, but if you go a negative 3, then you have to go a negative 1, because here, I'll do it over here. If you have a slope of negative 3 over a negative 1, the negatives cancel, and you still have a slope of 3, just like we did over here. Okay, so let me try to draw the line here best I can. Not too bad. And that's our line. Okay, slope and y-intercept. Second example, we want to do point-slope form. Okay, point-slope form. So remember, this is y minus y1 equals m times x minus x1. That's the point-slope form. What's the information that I have here? The slope is negative 3/5. Okay, so m is a negative 3/5. And it contains this point. Okay, so we know we've got that point. All right, well, what can I plug in? Well, remember, this negative 7 and 5, that's just some random point on the graph, on the line that we're graphing. And so we can call that's what we're going to call x1 and y1. So now we're just going to plug those in. So y minus y1. Now notice, sometimes it's tricky because the y's come first here. And a lot of times people are tempted to look at the x, which comes first here. So notice when you set up the point slope form, make sure you're subtracting the y, which in this case is 5. A little tricky because that's the second number. People want to go to the first number since it comes first here. So be very, very careful. The slope is negative 3/5. We plug that in, and then x minus the x, which is negative 7. So again, minus in the formula, minus a negative makes this plus 7. Okay, so there it is. Now that's what they asked us for, was the point slope form. So guess what? We're going to stop right there. Later on, we'll do an example where we might want to write something in the point slope form and change it to slope intercept. Then you can go on. But a lot of times people get here and they feel like they want to go further. Hey, let's change this into slope intercept. Well, if they asked us for point slope form, stop when you get to point slope form. Okay? All right, now how do I graph this one? All right, well, on this one now, we don't have the y-intercept. We don't have that spot to begin from. But I do have this point, this x1 and y1. And that's on the line. And so I'm going to go ahead and graph it. So negative 7 and 5 is going to be right up about here. Okay, so there's negative 7, 5. And then once I have a beginning point, I just do exactly like what I did on the last example. I just count out the slope. And in this case, it's negative 3 over 5. So from here, I can go down 1, 2, 3. And then 1, 2, 3, 4, 5 to the right. And I put a dot. Down 1, 2, 3. And then 1, 2, 3, 4, 5 to the right. So I got a few points there. And then I'm going to try to, the best I can again, draw a line there. If you watched the last video, you'd see this kind of an angle line for me is a little challenging. So that was much better than the last time. All right, so that's our line. Okay, moving on, 2 points. All right, this time, what we have, we're going to have 2 points, 4, 9, and negative 2, 0. We're going to still try to write the slope-intercept form. So we're going to still try to write y equals mx plus b. Okay, well, we don't know the slope. I don't have a number to plug in for m. I don't know what b is. They haven't told me the y-intercept. Well, what can I do? All right, well, I do have 2 points. I have 4, 9, and I have negative 2, 0. So what we can do with 2 points is we can find the slope. Remember our slope formula? Remember it was y2 minus y1 over x2 minus x1. So let's plug it in. Let's call the 0 as our y2 here. So I'm going to go 0 minus the first y, 9, over the second x, negative 2, minus the first x. So this is going to be a negative 9 over a negative 6. All right, if you remember from our slope lesson, we always want to simplify the slope if we can. Okay, so the things that we can do here, the negatives will cancel, so that cancels out to become positive, and I can take both the top and the bottom and divide by 3. 9 divided by 3 is 3, 6 divided by 3 is 2. So this is our slope then. 3 halves is our slope, so this is m. So yay, we figured out our slope. Okay, we got our slope. But don't we still have to figure out, somehow we still have to get a b to plug in here. All right, so here's where you can go a couple of different ways here, all right? The first way is we can plug this into Pointslope form. And then we'll just change it in to the y equals mx plus b, okay? So what that means is I have a slope now, and I have 2 points. So which point do I use? The answer is either one. They're going to give you the same thing. All right, so whatever one you think is easier, use that one. So in this case, I'm going to do y minus y1. Let's use this one. The numbers are smaller. Even though we have a negative, let's use this one. So y minus 0 equals 3 halves, and then parentheses x minus a negative 2, so plus 2. That's Pointslope form, but remember what we're trying to do is get it into slope-intercept. So what I'm going to do, first of all, since this is minus 0, I can just drop that. So it's just going to be y. And then I'm going to distribute the 3 halves over here. So this is going to be 3 halves x, and 3 halves times 2. Remember how you multiply fractions? If you have 3 halves times 2, that's going to be 3 halves times 2 over 1 is how that's going to work. You could cross cancel here just to get 3, or just multiply across 6 over 2 and then divide. So we're going to end up with 3 here. So this will end up being plus 3. And so there is our equation in slope-intercept form. All right, let's graph it. So where do I begin? I begin at 3. It's going to be right here. And then how do I move? I move by going up 3 and 2 to the right. So up 1, 2, 3, and 2 to the right. Or I could also go 1, 2, 3. If I go down 3 and then I go 2 to the left, that way the 2 negatives will cancel each other out there. And so this is the line. Now, there's another way that you can do this, and I'll show you this here. Some people like this better. I'm going to try to fit it in where I can. I've used up a lot of space here, but I'm going to try to fit it in. So I'll make a little squiggly line here, put it in this area. We can also do this by going directly to y equals mx plus b form, plugging in what we know and finding b. And then once we find b, we just plug it in. All right, so we know that m was 3 halves, right? So I'm going to plug that in. B is what I'm trying to find. That's what I don't know. But what do I do with the x and y? What I can do is, kind of like what I did over here, just temporarily pick either one of these points and plug it in for x and y, because they should work. There's, obviously there's more than one combination of x and y's that'll work, but each one of those will work. So let's say this time, because I did 0, -2, or -2, 0 on this one, let's do the other one here. So 4, 9. So that means y is 9 and x is 4. Okay, so what happens here? We got 9 equals 3 times 4 is 12 divided by 2 is 6. And then we do -6. And so B equals 3. Now that you know M is 3/2 and B is 3, guess what? Y equals 3/2 x plus 3. And you know what? Oop, there it is. I kind of took a little detour there. Look, it's the same thing. 3/2 x plus 3. So you can do that either way, either by plugging in what you know into y equals mx plus b to find b, and then you can just plug in your m and your b like we did on the first one, or go point slope and rearrange it. One other thing here, I don't know if this will come up on my other examples, but one other thing, just a little shortcut. If for some reason one of these points that you get, like in this case, another point that would work in here would be the point of 0, 3. How do I know that 0, 3 would work in there? Well, we figured out down here that 3 is the y-intercept. And if you look at that right here, 0 left and right and 3 up, that's the y-intercept. So I know that that point of 0, 3 would work. If they happen to give me, say, 4, 9 and 0, 3 instead of -2, 0, I could take a shortcut. I wouldn't even have to do all this work in here. If I see that I have a 0 as my x value, I know that the number, the y that's with it, is the y-intercept, and I could just plug that straight into the equation. So a little shortcut there. All right, horizontal line. So we want to write an equation. We have 2 points. Okay, so you should at this point be saying, oh, 2 points, let's find the slope. So slope, we're going to take the second y. y2 minus y1 over x2 minus x1. And so we say, well, this is going to be 0 over a -5. So we talked about this before. That means our slope is 0. Okay? So our slope is 0. Okay, but so we know our slope is 0. And hopefully you can remember that if we have a slope of 0, the line is going to go straight across. Let's just graph these 2 points and just check it out. So 5, -2, it's going to be a point right there. And then 0, -2 is a point right there. So yeah, you see, here's our line. Slope of 0 means it's going to go straight across. But what's the equation? Okay, how do we do the equation there? All right, well, let's try, since we have the slope and we've got some points here, let's just plug it in, say, to point-slope form. So y minus, and let's use this 5, -2 point here. So y minus a -2, so plus 2, equals slope 0 times x minus 5. All right, well, what happens here when we work this out? 0, remember before I distributed that? So 0 times x, 0 times -5. 0 times anything is always 0. So that means I've got y plus 2 equals 0. And then I say, oh, well, let's just keep getting y by itself. So minus 2, y equals a -2. Well, that must be the equation then, right? And it is. And if you look at this, the reason why this is kind of weird is we had 0 slope, so it got rid of the x. What this really just means is y equals -2 means y is always -2. It doesn't matter what x is, y is always -2. Look at our graph. If x is 1, what's y? -2. If x is 2, what's y? -2. If x is 3, what's y? Negative 2. It's always negative 2. So our equation here for a horizontal line with zero slope will always be y equals a negative 2, in this case, or y equals whatever the number is, depending on where the line is. But in this case, y equals negative 2. All right, what about a vertical line? Okay, a vertical line. Well, let's find the slope. You may already remember this about a vertical line, but let's just punch this in anyway. So negative 2 minus 4 over 3 minus 3. So this would be negative 6 over 0. Oh, 0 is under. So remember, if 0 is under, it's undefined. All right, so that's our slope, is we have undefined slope. Well, you know what's weird about this, though, is I can't go in here and plug in undefined into an equation to find out what the equation is. So how can I go about this? Well, let's graph the line. So let's go up to 3, 4, we got a dot. And then 3, negative 2. And so this line is straight up and down. Well, remember what happened on that last problem there, that last example, when we had a line that was straight across. The equation was y equals whatever number that was. Y equaled negative 6, or y equals 5, or y equals 2. It's a line that goes straight across because y always equals that same number. Well, if you look at some of these points here, it's exactly opposite. What if y was 1? X would be 3. What if y was 2? X would be 3. What if y was 3? X would be 3. So in other words, x is always 3. So our equation there would just be x equals 3, because in this case it doesn't matter what y is, x will always equal 3. So it's very similar to that last one, except for instead of y equals, this one's going to be x equals. All right, now here's kind of a little overview of what I just talked about. Notice here that if you have a horizontal line, y equals negative 3 is the example they've given here, and here x equals negative 2 is straight up and down. The one thing to keep in mind here is this. A lot of times people get these confused, okay, because the y-axis goes up and down. They seem to think that a line that goes up and down will be y equals, but notice, no, that's x equals, okay? Y-axis is straight up and down. X equals, that line is straight up and down. It's a little weird. X-axis goes sideways, but a line that goes sideways is y equals. So keep that in mind. If you can remember that, it doesn't match the axes, it crosses. So like if you have x equals, that line is going to cross x. And if you have y equals, it's going to cross y. Okay? So be careful on those. All right, we want to write an equation in slope-intercept form for a line parallel to this that passes through negative 1, 5. Okay, so let's look at this on the graph first. First of all, we got negative 1, 5. Our line, here's what's happening, is our line is going through that point. It's going to be parallel to this line. Okay, well, let's just graph that line just so we can look at it. 3x minus 2, so that means we begin at negative 2. We go up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. So this other line over here is something like that. And our line is going to go through this, and it's going to be parallel. So it's going to be the same slope, right? We just have to figure out what that equation is. Here's how I like to set it up. Because these are two separate lines, I like to draw a little squiggly line down the middle. Since it's parallel, I'm going to write up on top here that it's parallel, just so I can remember. On one side, we've got the y equals 3x minus 2. On the other side, we've got the point of negative 1, 5. Those are two separate lines. All right, so what do we know about parallel lines? They have the same slope. So what's the slope of this line over here? The slope of this line on this side is 3, right? It comes from that right there. All right, if it's parallel to my line, Now when I move it over to this other side, if it's parallel, it stays the same. So it's also going to be 3. All right, so now we've got a point and we've got a slope. What do you think we could do? Point-slope form. So y minus 5 equals 3 times x minus a negative or plus 1. There's our point-slope form. We want it in slope-intercept, so let's just change this slightly, distribute. So y minus 5 equals 3x plus 3, and then add 5. Oops. See, my brain was thinking ahead there. And so y equals 3x plus 8. So that's our equation. And if you look here, the slope is 3. The slope is 3 on this one as well. It just has a different y-intercept. Okay? And so if you were to count this out here, and you went up 1, 2, 3 and over 1, somewhere about right there, what point would that be? If this is 6, that'd be 7, that'd be 8. Oh, look, that's the y-intercept. And so, yeah, that line would go something like that. Parallel lines. Okay? Last example. I know this is getting a little long, but here's our last one, I think. Perpendicular. Okay, same situation, but this time it's perpendicular. So we know our line goes through the point of 2, 0. Let's plot that point. Let's set it up here. Okay, so here's I'm going to draw my line down here. This time, since it's perpendicular, I'm going to write perpendicular up here. This line is y equals 1/5 x plus 2. And our line over here goes through the point of 2, 0. All right, well, let's go through the same thing here. So if this line, we want to know what its slope is, and its slope is right here, 1/5. All right, so now I run it through the perpendicular machine, and when it comes out on our side, what happens? It becomes a negative reciprocal, so it's a slope of -5 over 1, or just -5. Now I have a point and a slope, so I can write the point-slope form. So y minus 0 equals m, -5 times x minus 2. The 0 can just drop, so y equals, and then distribute, -5x plus 10 would be our equation there. And then just to see how this would look on the graph, remember this is our line here going through 2. Remember the slope is -5, so that means it would go down 1, 2, 3, 4, 5 and over 1. Or it would also go up 1, 2, 3, 4, 1, 2, 3, 4, 5 and over 1, and then again up 1, 2, 3, 4, 5 over 1. So somewhere up about in here, which it looks like that would probably be where 10 would be, and which matches up with our y-intercept there. So this line would look something like that. And then the other line would be y-intercept of 2, and it would go up 1 and over 1, 2, 3, 4, 5. So something like that. And so you can see that those are perpendicular lines. Okay, well, there you go. That's it for today. Hope you enjoyed that. That was section 3-4. And this is Mr. Anderson. Until next time, take care of yourself.